All right, good morning, everyone. Welcome to our weekly storage API sync. Today, we're going to talk about the progress on archiving Kusama on the Aries testnet, and we're also going to talk about Subspace JS a little bit and initial steps there. So to start off, I'll hand it off to you, Serge, if you want to give us an update on your progress.
Sure. Let me share my screen. So before I give you overview of the progress on processing blocks from archive, should we walk through my previous PRs, like from the last week?
Yeah, I think that'd be a great place to start.
Yeah, so there were 3 PRs merged last week, and yeah, one was I was working on resyncing blocks. So every time we restart relayer, we process blocks that are missing. And here we also have added new parachain kintsugi, but yeah, this is minor. So this is the actual implementation. And in the index file on the relayer backend, we have this function process source blocks, and it accepts the target. Yeah, we're using partial application here. So because target is only one instance, we provide it to all sources. And so first argument is target, second is the source. So for each source chain, well, let's say in this case, we only have Kusama. We check if we have already resynced the blocks and what was the last finalized block. And initially this value is undefined, and then we subscribe for the new heads. And if we are resynced, we just process new headers as we did before. We get blocks by hash and we submitted transaction. And if we are not resynced, then we resync first and we subscribe for the resynced blocks and send transactions. And after we complete, we change the flag to true. Yeah, it looks a little bit not quite elegant, but yeah, this is the implementation we have at the moment. And yeah, this is how we use this function. So for every source, which is currently an array of one source, one item, Kusama, yeah, we call this function with a target. And what else? Yeah, everything else just extracted this code to a separate function and everything, and added some comments. Everything else is the same. Any questions on this?
Nope, not on my end.
Okay. And another PR was focused on transaction size. So we limit transactions by 5 megabytes. And here I put some reference on the GitHub issue where this value was mentioned. And I also tested some values like more than 5 megabytes and less than 5 megabytes. So everything which is less than 5 megabytes is not rejected by our node and Substrate node in general. So yeah, it's pretty straightforward. We take a payload, which includes our block, whether it is hex or stringified JSON, metadata, and yeah, we stringify this object and we calculate the number of bytes, and we have this constant of size limit, which is 5 megabytes, and we just compare if it is less than 5 megabytes. yeah, then transaction is within size limit. And yeah, this is the actual method, and this is how we use it. Previously we were merging relay block with para blocks and return observable of blocks. So now we added this pipe. So basically from this observable we filter out all blocks which are exceed 5 megabytes limit. And that's it. Quite small.
I actually do have a question here. Why do we JSON stringify the payload?
But I'm unsure we can use buffer byte length with JSON. Can we?
But is the length of the transaction computed from JSON stringified value on the node side? We should use exactly the same mechanism for checking the length. What is the mechanism there?
Could you repeat?
So there is some mechanism which checks the size of the transaction on the node side.
Yes.
Do they also use JSON stringify?
On the node, not sure.
Well, but the check should be exactly the same. Otherwise, we are not sure if we are even comparing the same value. Maybe there is like 3 more bytes we can include that we don't, or maybe there is the length check basically is not correct, and we include something that shouldn't be included.
Yeah, but I was testing it this way.
Right, but you might be able to include some more bytes, and instead we just don't include it at all.
So right now it's an optimization problem, not a failure problem.
Yeah, I think so.
And also, why do we filter instead of, like, it should probably crash. We should never even have transaction that is bigger than the size limit.
And previously we discussed that we just skip those blocks that exceed 5 megabytes, exceed limit.
But then we are not archiving the history. We are archiving some part of the history which we don't even know which part of it.
We can crash if we can agree on that.
We talked about this. I thought it was at the offsite, or maybe it was one of the calls, but we had decided that for now we didn't want to crash the relayer because we had a big block, because it would crash everything. So we said we're just going to accept the fact that in this testnet mode, this might occasionally happen. We just want to get like a warning or a notification or a log event of this somehow. And then we will, the next step is to handle chunking, where we could chunk that block out across multiple transactions. We're just not there yet. But we don't want to like kill the whole relayer just because this happens. And it's almost impossible for it to happen, because at least with Kusama,
well, if it's impossible, that's panic. So we know for sure when it does actually happen, because otherwise it will be just somewhere in the log that no one will read. Like, it's quite important, I think. If there is something that we do not expect, we put expect call in Rust. We just crash the whole thing if it's something that is completely unexpected. We do not really expect even a megabyte in Kusama, I think.
I mean, do we really want to kill the whole network just because we had one block that was too large? I mean, that seems like that's a little bit extreme. Well, there might be like people relying on the relayer for third-party services.
Right, but we do not expect to exceed 5 megabytes.
I mean, it seems a little bit extreme to crash the whole app just because we get one unexpected case. It seems like maybe there's a more practical way to, I mean, I hear you, like if it's just logged, we might not never notice it, but maybe there's some other way that we can ensure we get notified.
Yes, there is other way. The other way is for production applications to actually have a monitoring system where every unexpected case will be like in a separate metric, and we can create alerts about that. But that's like something we do not have and probably will not have in the very nearest future. So if there is something really, really unexpected, like 5 megabyte block in Kusama, how realistic that is? They like have 30 kilobytes. Let's just crash.
Yeah, for Kusama it's not realistic, but for a parachain could be.
I don't think so. I think it should be the same limit as Kusama, because they're all in the same block time. I mean, at least as far as I'm aware, they're all in the same block time. So they've still got the 30 kilobyte roughly limit, or else they're just going to fork like crazy. Okay, let's just go with crash for now. We just need to create a ticket to do a monitoring service and make this more robust in the future. I think the likelihood of this happening is like 0.001%, so we should be okay, but we just need to make sure that we handle it in the future.
Let me create tickets. So what was the first one? So use same mechanism as on the node side, right?
Yeah, for measuring the size of the transaction.
Okay, and the second one would be if action transaction size limit crash, right?
Yeah, well, there's two tests there. That, I mean, that's the immediate thing, is to crash. The second thing is to add a monitoring service so that we don't crash, but we still get notified.
Monitoring is a little bit on infrastructure side because we'll need to have some Prometheus server which will scrape metrics and some dashboard which will send alerts, and then we can connect application to it.
So what about this one? Do we want it? How prioritized should be?
And that's like one line of code, right? Should be pretty simple to implement.
Yep.
Yes.
Process exit one.
Yeah, let's just put that in the in progress or the next steps column.
Okay. Anything else on this one?
I had a question actually on this stringify to bytes. Is there another PR you're going to talk about to cover this data handling or the data conversion, like the binary conversion?
No. Another PR is related to this one. But
Okay.
yeah, it's not about data conversion.
Okay, Nazar, you told me that you had some new ideas on how to handle this that you were dealing with in some of your scripts that you were writing to parse data and put it to the RocksDB database.
Yeah, the solution is always the same. Just go to the source code of Substrate and see how they do it. And I just did that in the script that downloads blocks. So it can be like moved from there to some utility file and reused.
Does that make sense to you, Serge?
It's already implemented.
But we're using that already for archive blocks. I just had no time to implement, to like integrate it into regular blocks, syncing, resync and stuff.
So are we storing the data in a different format if it's in the RocksDB database versus if we're fetching it in real time from the network?
Currently, yes.
Okay. So how hard is it to upgrade to make them consistent so that we're storing it the way Nazar does as in the RocksDB database?
Not hard, just needs time.
Well, how much time? Like, is it a major refactoring, or is it just copy and paste these functions over?
Yeah, I think just change a few lines of code.
But this is going to vary by parachain. It's not consistent.
It is universal. It works.
Yeah,
for
it's
any parachain.
universal.
Oh, it's universal.
Yeah.
Okay.
We have same
Okay.
processing, yeah, for all chains.
Okay, then let's also add that. So because otherwise, it doesn't. We're storing the data like inconsistently. Then we have to like read it with some case or something. It just starts to get really messy.
Okay, so
You can put that in the not started column.
I think.
Oh, you've already got it there. Okay.
Yeah, I think this one is. We can make it within this ticket.
Okay.
Okay. Anything else?
Oh, that's all. Keep going, Serge.
Okay, and the third PR was yeah, like a minor fix for the previous one because I forgot to bind this method to the yeah, it's like JavaScript context related stuff. And we also log errors or error messages now instead of just logging the whole error object. Yeah, very minor one. Any questions on PRs?
Nope.
Okay, so and currently I've been working on processing archive blocks, and yeah, since we last spoke, there was some improvement in performance. I can show you. So previously, when we were submitting block transaction, we had this nonce -1, and this is related to the Polkadot.js documentation. So if you don't know what is the current nonce, you can specify -1 and it will fetch the value under the hood. So it was actually calling RPC. And instead, now we can provide nonce explicitly as a parameter. So here you can see there is this parameter nonce, which is optional. And if we provide it, then we use this value. Otherwise, we use same as before, -1. And here in chain archive, no, actually it's not here. When we subscribe to transactions from the archive right here, we query the nonce value from the RPC only once, and then we use it and we just increment the value by adding 1 every time we finish processing particular block data. So this way we can, let me show you. Yeah, we can somewhat increase performance. So previously it was like around 10, 14 blocks, transactions per block. And now we will have, let's wait a little bit. Where is it? So now we have, for example, let's reload just in case there are some older blocks here. Yeah, this is what I mentioned before. Sometimes when I run the node for a long time, block production is quite long. But why doesn't?
It is
Okay.
probabilistic.
Yeah.
Well, we're
so,
over 15,000 now. That's the limit that we put for the fast block time, right?
Assuming that is the latest version of the node.
It is the latest. It's when I started, it's 1 second, and sometimes it's still 1 second, but sometimes it's not. So it's not very consistent, but we have like up to 300 transactions per block if we are lucky. So
but that's for like the 10-second block time ones. I guess it just depends on the block time.
yeah, it depends on the block time, but it's still better than it used to be before. And yeah, another thing I was trying is hashing block, but so far I tried different hashing functions like Blake2, and which is used in Substrate, but somehow I still get different results. So I will need to check the source code on Substrate more. And what else? Another thing I was working is, so currently when we read blocks from the archive, we have this last processed block number in the database. So in the folder of Kusama archive, we have this last downloaded block, which is stores block number, and this block number will eventually update, right? Because we keep adding new blocks. So I was working on implementing functionality so we can watch this file and update this value in the code. And
you don't need to watch this file. This file is only updated when you download things, but you will not download things and read the same downloaded archive at the same time. It's not supported. So either download blocks and fill this archive, or you read it, not two at the same time.
Sorry, can you repeat again?
It's like running two MySQL servers from the same folder. It's not how it works. So this RocksDB database can only be used once. You either use it for writing or for reading, because these are like different applications.
So how do we update this value then in the code? Because it might change, right?
Just when you want to update it, you run the script, target the same folder, it will just fill the folder with new blocks. And script will exit once it reaches the head.
So do we have this script already, or I have to implement it?
Which script? Downloading?
So when you download it from the network, you update this file, right?
Under Tools folder, there is download substrate blocks script. This is like a separate application. This is what will download blocks and store them in database. You don't need to update the database in the runtime.
No, but I'm not updating database. I'm just reading from it. But we keep adding new blocks, right? While we are running.
Where?
Relay.
You don't add anything to that database.
Okay, so we can assume that this is a constant value.
Yeah, it's like read only for you.
Okay. Okay, then
yeah,
it simplifies.
Every time you start the relayer, you can just assume that's a static value. Now, if we have to relaunch the testnet like a week later, that value might have changed because that script might have been rerun in the meantime, and there might be more blocks in there. But from the point of view of the relayer during the seeding process, it's a static value.
Understood.
And for the most part, you don't even need to worry about that file called last downloaded block, because you just read the database. You read that at index 0, 1, 2, 3. If some index says I don't have this block, then you're done.
Yeah, with generators it's easy, but I had to use last block number when I had observables, RxJS, because I had to know when to stop the observable.
But you will reach, you will get null or error or something. I believe it's like an exception of some sort when you try to get a block which doesn't exist.
It's fine with generators, but for observable, you need to know when you should stop explicitly. So anyway, since we are not using observable now, so in this class at least, yeah, I can just assume, I can just not use it at all. Yeah, I guess that's it on my side.
Okay, I have a couple of questions. Can you just walk us through? You can do it in the code if you want, or you can just explain to us, like when we're seeding the block database, or sorry, when we're seeding the relayer from the block database, like from Genesis until we get to the network, like how does that process work, like step by step? I still don't have a clear understanding of like how that's actually happening.
So we have two modes for relayer. We can run it in the standard mode, which will fetch blocks from the RPC, same as we did before. And we have another mode, which is like, we can call it archive mode, then in which we connect to the RocksDB and we fetch blocks from the RocksDB. And yeah, I can show you the code. So we have this chain archive class, and basically we call getBlocks method. And it's a generator function. It returns async generator with a transaction data value. So we we know what is the last process blocked. In case we are processing from Genesis, it will be 0. Or if we are not processing from Genesis, it will be some other value from that we stored in our state previously. And for every block number, we fetch block bytes from the database, from the RocksDB. And yeah, we still need to somehow get hash. And we create this transaction data object, which contains the whole block as hex, block number, hash, feed ID, chain, and the account which will sign the transaction. And yeah, we save this in the state, and we yield this data object if payload is within size limit. So this is how we use it in the index file. For every archive, we get the nonce value, and then we use this getBlocks function, which returns, which is a async iterator. And for every block data, we submit transaction. It's pretty similar to how we used it with observables, but this actually simplifies code a bit. Does that answer your question?
So if you can go back to the code, sorry. So the section where you had a bunch of stuff commented out, that was where you were talking to the network before, where you're trying to get the hash to work instead?
Yeah, so this is what the real hash, and these are my attempts to get it without network request.
Okay. So once we have that working, there will be 0 network requests inside this. So we'll just do everything locally from the Genesis block until it gets to the head of what's in the RocksDB database.
Hopefully, yes.
Hopefully.
Yes.
I mean, it seems pretty yes or no to me, but are you saying that there's more code that we still need to remove, or just once this works, we won't need to make any more network requests?
No, there won't be any network requests. Yeah, this is the only one. We'll just read from the database, and this will be the only async operation we have.
Okay. Can we drill down on this hash problem and figure out what's going on here? Is there a way to resolve this? This seems like a big blocker that's stopping this right now. Is there any way you can help out with this, Nazar?
Yeah, I would just need to check the substrate source code in more detail.
Okay.
I just had no time to do it today.
Okay. All right. Okay. I'd still like Nazar to look into this, or us to sort this out sooner. It should be pretty straightforward. So once we fix this hash problem, then we will be able to store. So right now, like when you're running it, what you just showed us, you're not storing it by the correct hash. You're just kind of storing something in there, but it's not matching what it should be.
Yeah, I provided some hash, but it's not the actual hash.
Okay.
So performance will be the same if we remove this RPC call.
Okay. So we have 3 problems basically right now. So one is that we're storing the data differently in a different format if it is archiving from Genesis or if it's archiving in real time, because the data is not formatted the same. The second problem is that when we're archiving it from Genesis, we're actually inputting it under the wrong object ID or the wrong hash, because we're not getting consistent hashing here. And then the third problem is the transaction throughput is better, but it's still like maybe it looks like it's 50 transactions per second, but we should be something closer to like 1,000 transactions per second. So we're still looking at like several days or maybe a week to upload like Kusama history here, when it should be like less than a day. So it looks like we've removed the main bottlenecks in the code. I didn't see anything that was blocking there. Did you notice anything, Nazar, that was like that could have been async that was blocking in that workflow of writing in?
Async is not necessarily faster. Let's start with that. We just were
Okay.
doing some things that we could skip, so that's nice to eliminate. I think the network delays are the primary thing, but again, that can be tested very easily. You can just add one timestamp, second timestamp, and do the difference, or use like performance or like log start time or something. There's basically an API in the console in Node.js that you can use to time things, so we can find where most of the delay comes from.
You mean when network delay? You mean the put request or the
Pull
send
request or
transaction?
anything else. Like we can basically profile and see like where we spend most of the time, whether we are waiting for the put call or something else.
Are you familiar with doing that? Have you done that before, Serge? Something like that?
Yeah, a little bit.
Okay. Okay. So do you think you can get all of those done tomorrow, Serge? Like fixing the block data format and throwing that error and getting this hash resolved so that we can start uploading over the weekend?
Hash result, I'm not sure, but everything else should be fine.
Let me look into the hash. It might actually involve some changes on how we archive potentially. So I can just look into it.
Okay. Yeah, everything else, I mean, changing the block format and what was the second one?
Second one was throwing the error, like you already noted in the ticket.
Crash the app, yeah, if the block size, yeah, that's easy.
Okay. And do you have a ticket for the hashing issue?
For the hashing issue, no, I was working on this within my current ticket.
Okay.
I have a note for myself. I will check it.
Process all blocks from file system. Yep.
Okay. And then what about extending to the parachains? What are we gonna have to do to do that?
I will need to download like a database with the parachain data, and probably it should be the same mechanism. So we have this in the config. Let me show you. Yeah, so previously we had this source chains array with Kusama, and it had a property of parachains, so it was like hierarchy. So in this case, we will just have a flat array of databases. We just provide a path. If we remove this request for block hash, we might not even need this URL. So it will be just an array of paths to the database. And we create instances of archive class for everyone and just fetch blocks.
Is that going to all work off the same event loop for Node, like on a single core?
Yes.
Okay.
It's not out of CPU work, so it should be fine.
Okay. So the relayer, like when we're doing this for like 15 or 16 chains in parallel, that's probably not going to block the fetching or the writing, I guess, reading and writing.
It's all network. It will spend most of the time sending and receiving bytes or waiting for an event.
Sorry, it's all network or it's not network?
It will spend most of the time waiting for network. This is like perfect for Node.js.
Okay, but it's not doing any GET requests over the network. It's just reading from the disk. It's only sending the
Right,
transactions
but it
out
will
over the
still
network.
wait for disk to return bytes, and it will wait for put call to succeed. You cannot just do it at the speed of CPU processing.
Okay. Okay. So you need to download a parachain. Which parachains are ready, Nazar, for download?
It's Altair, Basilisk, Killed SpiritNet, Kintsugi BTC, Perl Heiko, and StateMine.
Okay. Which one of those is the smallest?
Let me check. So Perl Heiko is 260 megabytes. StateMine is the biggest one, 2.5 gigabytes. Kintsugi BTC is 52 megabytes. Killed SpiritNet is 700. Basilisk is 500. Altair is 400. Yeah. So Kintsugi, I think it's the newest one out of the
Yeah.
bunch. So it's just 52 megabytes.
But Kintsugi would not start actually uploading until you get to the head of Kusama. So you can't really test that until you get to the very end.
Actually, I had another idea about all of this. For some reason, we are trying, like, I know why. We are trying to subscribe to the blocks from Kusama. And then when we see something included from the parachain, we will try to download that. What if we just subscribe to all of those parachains? And as soon as we see block finalized on the chain, we can archive it. Then instead of having like one relay chain and dependencies, we'll have just a bunch of chains. Doesn't matter if it's relay chain, parachain, whatever. They can even be like mixed Kusamas and Polkadot's chains together, just one flat list. We just do all of them in parallel. We will have more subscriptions, that's for sure. But I don't think it will be a big problem for Node.js to handle.
Are you talking about for the archiving process or for the real-time relayer?
For the real time. Like we'll basically erase differences between relay chains and parachains and make like one code path.
Yeah, this was the initial implementation, actually. But we were concerned about the order. How should we maintain order if we process them all in parallel?
No, I mean, we can process every chain sequentially. We just need to process multiple chains in parallel. So within each chain, it will be correct order. But some blocks may like jump ahead of the other ones if RPC is slower.
Well, we can't subscribe to the parachain blocks. I mean, the parachains don't really say when they're finalized. The relay chain says when they're finalized.
I think they do. That's how I download them from the parachain node. They do actually know when they are finalized. That's why when I just start the node, it tries to sync both relay chain and parachain. However, the relay chain, the parachain, even though I have blocks, they are all not finalized until relay chain reaches to the certain height. That's probably why they actually run the relay chain node, like client within the parachain node.
Oh, hold on. So when you're saying when you run so you're saying when you run a local archival node of a parachain, it knows when it's finalized, or when you're requesting it over like on finality?
If I subscribe to on finality, they also run archival nodes. So either way, I know what is the finalized block. I don't think they show it in the interface in Polkadot.js, but it is in the like console output of the node itself.
Well, there's I mean, there's like a trust verification challenge here. So I mean, it kind of makes sense if we treat these all as dumb data feeds. But if we want to actually have validated data stored in the chain, then it's much easier just to wait for the finalized Kusama block, which we can validate, and then use that as a dependency to say, okay, now everything else is valid. All of these parachain blocks are valid, and then fetch them. Otherwise, we kind of have to like, because we still would either have to verify the parachain blocks, or as the parachain blocks come in, wait and say, well, was this actually seen in the relay chain? Or is that relay chain block valid that this is saying it's finalized from, right? Does that make sense?
Okay, I see what you're saying, yeah.
So that's the main reason we switched the implementation to the way it is now. Okay. All right, so that was a bit of a tangent there, but I think the point that we were on was that during backup, like if you wanted to test Kintsugi BTC, you'd basically have to wait to run the Kusama archiver, which is going to take a week right now. So you have to wait 7 days, and then at the last hour, you could start testing Kintsugi BTC. Because if it's working the same way that it is in real time. But maybe, no, it's not, okay.
No,
so how does that work?
So currently we have those archives are like equal. There is no hierarchy. So they are independent. We process them separately.
Oh, so it assumes basically that somebody else has already done the validation that these chains are finalized, and then it just treats them as data to input.
Yeah.
Okay. So when you start the parachain block, it'll start at 0 and go up to the current head. And then it won't actually, during the archiving process, it'll just write everything, but then the real-time relayer won't start extending blocks until it catches up with the Kusama relay chain, and then it will start syncing those.
Yes.
So do all of the archives need to be in sync in terms of the block height? Like for example, if Kintsugi BTC is 100 blocks ahead of the last finalized Kusama block that's in the archive, then whenever the Kusama archiver is done, and now we switch to requesting the blocks over the network and syncing that way, will those stay lined up as it says like, okay, I need this Kintsugi BTC block? Like, will it write it a second time, or will it realize it's already written that block, that feed is already done?
Yeah, this is something we have to think about. I don't know.
Okay. So it sounds like it will at least upload everything in parallel quickly for all the data that we have in the archive, but there might be some synchronization issues whenever we switch from archiving to relaying.
Yeah.
Okay. Okay, we probably need to create a ticket for that as well to make sure that we are able to synchronize the transition across all parachains without duplicating data or skipping data. Okay. Okay. Is there any open questions on your end, Serge, about the relay?
No.
Okay. Okay, great. Sounds like we're making progress. We're almost there. Thanks for the hard work.
Just a small update. In the Google Drive, the shared drives, there is engineering. I created a folder relayer and downloaded archives in it with all the torrent files for the relay chain and parachains that I have so far. And also on the DigitalOcean node on that drive, which is mounted, I've also created Kusama archives and uploaded all of them there. So you can use them for testing there if you need, or you can use it here if you need.
Can you share the link for that in Discord in the engineering chat, Nazar, for the Google Drive doc?
It's not a doc, it's a folder. Engineering, yeah, sure.
Do you mind sharing your
relayer instead? Do we have relayer or something? No. Okay.
No. Okay. Can you just open that up really quick and just show us, like give us a quick overview of that document?
It's not a document, it's just a folder with torrent files.
Okay, so it's just, all right. Well, maybe I just like to take a look at it so I can understand it. Okay, so it's just name of chain, date that it was last updated. Okay. Cool. And everybody has access to that, right? Everybody should have access to the Google Drive. Does anybody not have access to that? Everybody clicks the link, it works. Great. Okay. And in terms of the DigitalOcean, so you said you uploaded, there's a folder called Kusama Archiver in the volume. And what's inside that folder right now? You're muted.
A bunch of folders just like these torrent files, which contain the actual archives.
So all the ones in this Google Drive folder have already been uploaded?
Yes.
Awesome. Okay, so that's like halfway there. One, two, three, four, five, six, seven. Yeah, I think we're at 14 or 15, so it's about halfway. Okay. The remainder of those are still, you're still syncing on your computer? You're muted again, Nazar.
Sorry. I think some of them already synced. I see Bifrost is synced finally, probably earlier today. Some of the others are still in progress, but they are pretty high in terms of block height.
Okay, great. And what's the total size right now of that volume with those 7 or that folder?
It's 48 gigabytes.
Okay. So it's probably not going to get that much bigger, considering all the remaining chains are pretty small. So like 50, 55 gigabytes.
Well,
something like
River and some of the other ones which were earlier parachains, they will be slightly bigger.
Oh, that's true. Yeah, we got Moonriver and Akala still, so those will be big.
It will be like, I don't know, half to 1 gigabyte for each.
Okay, so about 55 gigabytes, something on that order. Okay. So you're basically making sure that as these things get as these parachains get synced, at least some initial state, you're gonna add these torrent files in here. You're gonna upload the data to the volume. Did you and Leo have a chance to sync up about the scripts and the workflow for how this is going to get updated? Okay. I talked to Leo one-on-one yesterday. Go ahead, Leo.
Oh yeah, as we want to repeat this maybe later, all this process with another parachain, maybe you can share me these scripts where in terms of how you are downloading this and archiving this.
Of course.
Yeah, and I can replicate that in my machine and work in a documentation to start automating this in the future. I was creating a couple of diagrams in terms of machines, Terraform, and how we can improve this. So maybe tomorrow we can check that. And I think that I just need the scripts to start working on that, on a functional way to do this.
Where are those scripts at right now, Nazar?
The downloading script is in the GitHub. It's in the main branch. The only other kind of scripts are Docker Compose files that I have for the archival nodes, but you probably won't need them in most cases. Yeah, there are no other scripts.
Do you know where that script is in the relayer, Leo? Do we need to share a link for that?
I am looking for it.
Backend source tools. There's just one.
Backends source tools. It's just this one, right? This download substrate blocks. It's just this. Oh, yeah, perfect. I can check it. I can work with that. I thought it was some kind of system scripts.
No, and you can use that against archival node of your own, or you can actually use the on finality node public RPC. It will just be slower.
Okay. It's only here, yeah.
Have you shared the API key for on finality that they took off the rate limit with Leo?
No, no one requested that.
Okay, can you share that with Leo, please? If you need to put it in Bitwarden, whatever, or I don't think it's really a security problem, so you can just share that. Okay. Okay. So Leo is going to take over responsibility for ensuring all of these archival RocksDB databases for the parachains are up to date with some frequency. So this is going to be manual to start. As new parachains are added, he's going to add them in here, and then he's periodically going to resync them. Something like on a weekly basis is what we're thinking right now. And then we'll eventually make this more automated, more robust. We can run the archival nodes ourselves. We can sync it from the API. We can have the archival nodes hosted on Finality. There's a lot of different ways we can do this. So we just need to think about it as a team, what makes the most sense with the resources that we have. But ultimately, Leo is going to be responsible for ensuring that this data is backed up in the case that we need to redo the restart the testnet and have a canonical source of the seed data. Does that make sense to everybody? Okay. And as we grow, we're going to have Polkadot, all the Polkadot parachains. So that's going to be another folder in here. We're going to have Bitcoin. We're going to have Ethereum. This is like a non-trivial amount of parachains or blockchains that we're eventually going to be hosting right on here as we seed. So maybe something like by the time we launch mainnet, it could be 50 chains across Polkadot, Kusama, and like the key blockchains we identify that we want to host. So we'd like to get this process more robust and scalable and well documented, so that it's not a bottleneck as we deploy new versions of the testnet. Okay. Okay, anything else? Let's see. So went through Serge, went through Nazar. Anything else on your end, Nazar, regarding uploading of this data?
Not really.
Okay. Okay, anything on your end? Any questions, Leo, about this this backup process?
No, I wasn't aware about the script, but I think that I have all covered in my mind. No problem for now.
Okay. Okay, great. All right, let's talk about Subspace JS a little bit. So we discussed this on our call, on our Tuesday call a little bit, about trying to get an initial version or start scaffolding up Subspace JS. So we talked with Oskin yesterday quite a bit about the farmer and the backend for the farmer. And it looks like we're probably 1 to 2 weeks away from getting like a very basic RPC server working on the farmer, where we can request, we could send like an object request to it and the farmer could return an object. So this is in like a full replica mode where every farmer has the full history, and any farmer we call will basically be able to return any object which has been stored on the chain. So this is like the initial version of retrievability. So yeah, I think we're a few weeks away from having the put side, the put backend working. The get backend is working, but only for feeds. So we still need to implement this like, like dumb put, or like just put object alone, like put object outside a feed. I know we talked about like hacky ways we can do that, or we can create a new runtime call. And then, so that's the backend side of puts and gets, or gets and puts rather. And then on the front end side, we've got, Serge, you've got a lot of code which you've written for the relayer, which we kind of have to abstract and refactor into like a generic put call, and that returns an ID. And then we've also got to write the backend for this get side. So what I had originally hoped we would be able to do is to kind of split this work between both you guys, Serge and Leo, so that Serge, you were focused more on the put side, and Leo, you were focused more on the get side, because that's where I think you guys are having more experience, and it's good for both, you guys to have a really good shared understanding and cooperate on this project. But foreseeably, you're going to be working on Relayer for another couple of weeks, Serge. It's just, you don't have the bandwidth to do both of those at the same time. So I think it's going to make more sense, Leo, if you take over right now, at least, the kind of ownership of this project and get this working. Because this is like, this is the next big step, right? Like we've got the data, we've got one way to put data into the network. We really can't do anything with it yet because we can't get it back out. And it's like a lot of effort to put data into the network. You have to like know a lot about how this thing works. And we want to abstract it out so it's really easy for people to put data into the network. And then we can start doing a lot more interesting things with this backend, with this blockchain that we've built. So this is like a big next step. And then we need to start getting like feedback from developers and start working with partners, other parachains, you know, Monk or Subquery or Unfinality, people that are interested in building on this. But they need something to be able to do that, which they don't have right now without a lot of onboarding and education. Okay. Are there any like thoughts or comments on that before we start talking specifics about how this could work? Okay.
No.
Go ahead, Leo. Oh no. All right.
No.
Okay. So what I would recommend we do, Nazar, you already wrote this example API that you had shared in the Discord for Subspace JS. I think that, Leo, you should start with this as a scaffold and then just start building it look at probably just start with the put side, since there's a lot more that's done there, and figure out like how to get subspace.put working from that like scaffold that Nazar has built, and then looking at the code, like the latest version of Relayer, especially that like part about how do you actually put the transaction into the database, and just try to abstract that out so that we can have like at least subspace.connect or start or whatever it was we defined as the initialization, and then subspace.put. I would see that as sort of the low-hanging fruit, the easy first step to get started on. Does that make sense to you, Nazar?
Yeah, I think that API will have to be modified at least somewhat. It's just like a draft of what it could look like. So don't take it like a hard truth.
Yeah, it's probably going to change. It's just a version 1. It's probably going to change a lot once we get feedback from developers. But at least we can get something to work that we can demonstrate it with. Okay. Does that make sense to you, Leo? Okay. Yeah, and then I guess we can just talk about that next week, the first step. Hopefully by then we'll have a little bit more definition on the get side, and we can start working out the get half of the API as well. Okay. All right. Any questions from the group or comments? Okay.
Good luck, everyone.
Liu-Cheng, any feedback on any of this? Is it making sense?
Okay. I have a small question about the transaction size limit. Have you double checked that the size limit is really 5 megabytes for the normal transaction? As
Yeah, go ahead.
as I are you running the dev nodes of the latest master of subspace? I tested it locally.
Did you find something different?
Yeah, when I was reviewing the runtime configuration, I found that the block length for the normal extrinsic is actually 75% of 5 megabytes. So that is 3.75 megabytes for the normal transaction size currently. So I'm not sure if Serge is running the latest code or something.
I think that is just an artifact of the fact that we are not checking the actual length of extrinsic. We are checking the length of JSON encoded version of something else, and that
Okay,
something
that makes
else
sense.
will include
Okay,
hacks.
okay,
So it
okay,
will
okay.
it.
That makes sense. That makes sense.
Okay, so we're good.
Yeah, but when we change, we'll have to change the 5 megabyte limit. It will likely be 375 instead.
So is the intuition here, or is kind of the design of Substrate saying that like we can have a block size limit of 5 megabytes, but it probably doesn't make sense to have a transaction that's like at the block size, so that the max transaction size should be like
Well, you will
75%
have
of the
the
block
header.
size.
You will have the header and some of the other transactions. So I guess they are reserving some space, but it should be configurable. It's just like defaults. We should be able
Yeah.
to tweak it if you need.
Yeah. Well, and a lot of this is going to change too whenever we do the compact blocks where we're just putting transaction hashes in the block header anyways.
Yeah, but imagine like if you have a transaction which is so big that there is no space for the solution, you'll
Right.
not be able to put that transaction into any block ever.
Right. Yeah, it makes sense. Yeah, and that's probably just a reasonable. Yeah, there's got to be some cap on the transaction size, which is less than the block size to account for overhead for sure. Okay. Any other comments, Liu-Cheng?
Nope, not really.
All right. Is the audio or the connection working better now that you've limited it to a single video feed?
Yeah, much better now. At least I can join the whole meeting.
Great. Yeah, we figured out that you can actually on the receiver side you can limit it to a single video feed, and that was it was just too much bandwidth on Liu-Cheng's VPN. So now we should have much smoother connection. All right. Well, thank you everyone for watching. We will see you guys next week with more progress.